Students, today we have to study practice set 3.5, and before of it there is need that you must know the concept of what is meant by similar triangles or similar figures. So here now I have drawn here three different shaped pictures. In this first there is a triangle. Look the size of these two triangles. Here there are two circles are drawn, and here there is a rectangle. Then in case of all these figures, what is that? Every figure, these two figures have same shape. Shape is same, but sizes are different. Understand? Here also shape is same, but sizes are different. In case of these two figures also, what is the situation that shape is same, but sizes are different? Such figures are called similar figures. Do you understand? Have any problem? Now, once again I am going to tell you that geometrical figures or any figure which have same shape but sizes are different, such figures are called similar figures. Now we have to see little information about similar triangles. I am going to draw here two triangles. One is here, name of the one triangle is ABC, and the second one is the PQR. Then suppose triangle ABC similar triangle PQR. Actually, when are triangles similar, that we have to see, and that's why then I will write here first. Suppose in triangle ABC and triangle PQR. In triangle ABC and triangle PQR, angle A congruent angle P, angle B congruent angle Q, angle C congruent angle R. In your book there is written that A is equal to P, B is equal to Q, and C is equal to R. If they are equal, means they are congruent. Therefore, triangle ABC similar triangle PQR. By which test? There is a test that these two triangles are similar by triple AA test. Similarly, there is another one condition. Suppose same. In case of this, instead of these angles, if we write here that AB is equal to PQ, then BC is equal to QR, and AC is equal to PR. Means the ratio of AB upon PQ is equal to BC upon QR is equal to AC upon PR is equal to 1. Therefore, triangle ABC similar triangle PQR by triple S test. Now here we are entering into the new exercise, that is 3.5. Before entering, once again I am going to remind you that if you are not subscribed to the channel, please subscribe the channel. Please hit the bell icon and also write your comments, and don't forget to share your likes. Okay. Now we will enter into question number 1. What is the question number 1? That we will see first here. Please draw diagram. Please read yourself. There are two triangles given. Number 1, triangle XYZ similar triangle LMN. Similar triangle LMN. And here it is told to write the corresponding angles of two triangles and also write the ratios of corresponding sides. Okay, we will write if these two triangles are similar, then first angle told, so angle X congruent angle L, corresponding angles asked, so angle L will come. Okay. Now angle Y is equal to angle M and angle Z is equal to angle N. You may draw your diagram X, Y, Z, L, M, N. The angle X and L, angle Y and M, and angle Z and N are corresponding. Now we have to write sides, corresponding sides. Means what will you write? These are corresponding angles of similar triangles. Similar way, we will write sides. Side AB is no need to write side. Directly you may write that. What and how will you write? First pair XY, first pair LM. XY upon LM. Now second and third pair YZ here, second and third pair MN is equal to first and third XZ. Here first and third LN. What is the corresponding sides of similar triangles? Let's look here what happened. XY corresponding side LM, say the YZ corresponding side MN, say XZ corresponding side LN. By this way, this answer is here completed. These are the ratios. If here it is asked to write in ratios, first here it is written write the corresponding angles of two triangles and also write the ratios of corresponding sides. This corresponding sides we have written here, and again angles also I have mentioned here. By this way, now we will enter into the question number 2. What is question number 2? Please read and write question. If you want, you may draw diagram. In triangle XYZ, is actually it is mentioned that triangle XYZ similar triangle PQR. Similar triangle PQR. Then we should write first the corresponding sides XY upon PQ. XY upon PQ is equal to YZ, second third pair from second one, and first and last XZ, first and last XZ upon PR, corresponding sides of similar triangles. Now what is XY? XY is equal to 4. XY is equal to 4. YZ is equal to 6. And then what do you want? PQ is here given 8. PQ is given 8 and asked to find out the length of remaining sides. Means you should have to find length of QR. What do you want to find? QR is equal to question mark. XZ is equal to question mark. PR is equal to question mark. So we can find out. How can you find that? We will check here. Now first pair we will take 4 upon 8 is equal to 6 upon QR. Now do cross multiplication. 4QR is equal to 8 into 6. Therefore QR is equal to 8 into 6. This is multiplication. When it goes to other side becoming division. 4 ones are 4 twos are. Thus QR is equal to 2 6 are 12. 12 units is the answer. Don't forget to put the F4 sign. Once again, what I have done, look here, I have written here first corresponding side. Afterwards, I have added there. I have kept the values, given values, and from it, first and second pair is taken. 4 upon 8 is equal to 6 upon QR. 4 into QR is equal to 8 into 6. Now 4 goes there, becoming division, and thus you will get 12. Now what do we want there? Find the lengths of remaining sides asked up. So we will find length of remaining sides. How will you find that? I will tell you now. Thus QR what here? 12. Okay. What QR is equal to 12. 4 upon 8. 4 upon 8 is equal to xz upon PR. Xz upon PR. Then what is happening? That 4 ones are 4 twos are xz. Sorry, it is xz upon PR is equal to 1 upon 2. 1 upon 2. Now then here we will take, if you want to find xz and PR, then in that same ratio means we should have to take xy upon pq, means at last xz upon PR will also come 1 upon 2. That is the answer. And here there is, I think xz is also given to us 5. Yes, xz is given 5. So if we now we will take xz, you want to find next some sides. Therefore we will take here yz upon qr, second pair taking, second and third pair. Yz upon qr is equal to xz upon pr. Then yz is given to us, or xz given check. Xz is given 5. Here we have already calculated 6 upon 12 is equal to, this is 5 given. Then you want to find pr. How will you calculate now pr? 6 into pr, cross multiplication. 5 into 12, give cross. Therefore sign. Now PR is equal to 5 into 12 divided by 6. 6 ones are 6 twos are, and thus PR is equal to 5 into 2. 5 twos are 10 units. Okay. By this way we have calculated values whichever required. You were in need of QR and XZ, that we have calculated. Now we have to enter into the question number 3. What is question number 3? Please read. In question number 3, here it is asked to you that draw a sketch of pair of similar triangles. Label them, show their corresponding angles by the same sign. Show the lengths of corresponding sides. Means we should draw here first diagram. There are two triangles. These are the two triangles. Suppose A, B, C. This is P, Q, R. This is P, Q, R. Now angles told, angle A and P. I give same sign. This angle A corresponding angle P. Now B and Q, same sign. And here is three lines are, three circles are, three semicircles or quarter circle I have drawn here. Then what will happen? In triangle, there is already given to us similar triangle, so we should mention that triangle ABC, similar triangle PQR, and now then you should write the corresponding angles. I will write here angle A is equal to angle P. Angle B is equal to angle Q, and angle C is equal to angle R. Don't write there congruent sign, so cancelling this, and here it is writing corresponding angles of similar triangles, corresponding sides of similar triangles. Now we have to write sides. Then what is happening? AB upon PQ. AB upon PQ, first and second, AB upon PQ. Now BC upon QR, BC second, third, QR. This is third pair, AC upon PR, AC upon PR. You should write here corresponding sides of similar triangles. Understand? By this way, these two triangles are similar and how their pairs are corresponding to each other, that I have written. Now here this exercise is completed. I want to take some theorems, so please be ready to understand the theorems. Now, important theorems that are necessary to us. So I am writing first here theorem. What is the theorem? That first we will see that sum of two sides of theorem number 1, today's theorem number 1. Here I am writing theorem number 1. The sum of two sides of triangles is greater than third side, is greater than third side. Okay. So we will write given here. I am going to draw here one triangle. This is one triangle drawn here. Look. Now this is A, B, C. Then right here given, you want to prove this. So how will you prove that? Please check. In triangle ABC, in triangle ABC, or here it is directly told that, so we should have to change little given there, and what will you do? This thing. ABC is any triangle. ABC is any triangle. Then what do you want to prove? That you should mention here AB plus AC. AB plus AC is greater than the sum of two sides. Is greater than third side. This is number 1. Then, or you may write AB plus BC is greater than AC. Or you may write BC plus AC is greater than AB. Means in short, what is there? That sum of any two sides are always greater than third side. So how will you prove this? For that purpose, there is need to make the construction. What will you do? So then extend AB till D and join to C. This. Here I am writing here extend BA till D such that AD is equal to AC. That is the part of construction. Yes, do you understand what I wrote? Now, not to avoid confusion, I am erasing this from here, taking this side off. Okay, this is point D. Now we will see a proof. In triangle ADC, what happened? AD is equal to AC. Why? Construction. It is construction. Okay. Therefore, triangle ADC is an isosceles triangle. Why? If two sides are congruent, then it is isosceles triangle. Therefore, now angle ACD is equal to, base opposite angles are congruent. Angle ACD is equal to angle ADC. Okay, is it clear? Now then, adding here in this angle ACD, adding angle ACB. What will happen? If ACB is added, in ACD, this becomes greater than angle ADC. Then angle ACD plus angle ACB means what is becoming? Angle BCD becoming. Angle BCD. You may write but what is but? Angle ACD plus angle ACB is equal to angle BCD. So I will write here angle BCD is greater than angle ABC. Okay, correct. Now, which side is opposite to angle BCD? BCD's opposite side is BD. Therefore, side BD is greater than which side is opposite to angle T? BC. So I will write here side BC. Means what happened? Side opposite to greater angle is greater. BCD is a greater angle, then side opposite to greater angle is greater, means BD is greater. But BD is equal to what is that? BD is equal to BA plus AD. BA plus AD. Therefore, I am going to write BA plus AD is greater than BC. But AD means what? But AD, here take 1. Here AD is equal to AC. Therefore, you should write BA plus AC is greater than BC from 1. From 1. Therefore, what is their answer? That sum of two sides, BA plus AC, sum of two sides is greater than third side. Similar way, you can prove AB plus BC is greater than AC or BC plus AC is greater than AB. The remaining that two theorems means these two facts also possible to solve. Okay. Now we are going to study next theorem. You should have to study this all. There is need to do the practice again and again, because in case of exam, sometimes given will be given proof and told to prove, or simple statement will be given to you and you should have to prove the theorem. So these theorems are very, very important. There is two more theorems. One, now theorem number 2. Theorem number 2. Theorem number 2. What is that? If two sides of a triangle, one minute. Theorem number 2 related to perpendicular bisector theorem I am going to take. Every point on the perpendicular, every point on the perpendicular bisector of a segment is equidistant from the endpoints of segment, from the endpoints of segment. So just read now. Every point on the perpendicular bisector of a segment. Of a segment means we should draw here one segment. Okay. AB is one segment. Now what happened? Perpendicular bisector means line L is one perpendicular bisector. It is at M. Line L. So we should write here given. What is given? Please look. Line L perpendicular seg AB at M. Therefore, AM is equal to BM. Perpendicular bisector means what? It makes 90 degree angle and divides two equal parts of the main segment. Means seg AB is here divided into two equal parts. AM is equal to MB, and what is happening that at the place where there is a line L bisects, there 90 degree angle is formed up. Now I am going to take here any one point P. Okay. Now P is any point on line L. Then what do you want to prove? You should have to prove AP is equal to BP. AP is equal to BP. AP is equal to BP. Now proof. This we should, before writing the proof, that we should have to write here construction, join points or draw seg, not necessary to write join, draw seg AP and seg PP. Okay, seg PP. So then what will happen now? Look, proof. Just we have to write L perpendicular, line L perpendicular to AB at M. Therefore, angle AMP is equal to angle BMP. BMP is equal to 90 degree. Okay. Again, what is given to you? Directly now we will take in triangle AMP. In triangle AMP and triangle BMP, seg AM congruent seg BM corresponding, given, it is given to us, so we should write here reason given. Now what will happen? Angle AMP congruent angle BMP 90 degree angles, and this is common side, PM is common side, so write that seg PM congruent seg MP common sides. Okay. Therefore, triangle AMP congruent triangle BMP by which test? These are congruent by side, angle side, by SAS or SAS test. Okay. Therefore, now then what is happening? Seg AP congruent seg BP corresponding sides of congruent triangles, and therefore we should write AP is equal to BP. Therefore, P lies on perpendicular bisector. Actually, here I took, that is, we should not take here P is any point on line L. We should not take it, because what is told that every point on the perpendicular. So then here, then P means it proves that. What does it prove? Any point take. All points are always equidistant from the A points of segment. It proves that any point on perpendicular bisector is at equidistant from endpoints of segment. Understand? So by this way, this theorem number 2 is completed. Now again we have to see one more theorem. Don't move from the channel. You should study now theorem number 3. So please, once again I am going to remind you that if you have not subscribed the channel, please subscribe channel. Tell to your friends to subscribe the channel. Write your comments and share your likes. Now next theorem is there here given that any point equidistant from the end points, any point, I will write here theorem, any point equidistant from the end points, of a segment lies on the perpendicular bisector segment, lies on the perpendicular bisector. Okay, so then we should write here given. What is given? Any point equidistant from the end points. Means there is one segment. Same we will take. AB is a segment. M is a point. Now line L is a perpendicular. Line L is perpendicular at M. Then any point equidistant from the end points. Means AM is equal to BM will come. Now here P take, as you like you may take, and we should prove that. What will you prove? That P is on the perpendicular bisector. Means any point at equidistant is always at any equidistant point from the end points of segment lies on perpendicular bisector. Then here in given what will come? Line L perpendicular AB. You should prove. What will you prove? Then P lies on perpendicular bisector. In bracket I am writing here L of seg AB. Okay, of seg AB. So how will you prove? That is very simple. Look now, what is proof? We will write here proof. Directly I will go in triangle AMP. In triangle AMP and triangle BMP, seg AM congruent seg BM. Seg AM congruent seg BM. Seg PM congruent seg MP. This is common side. And seg AP congruent seg BP. This is part of given. This is also part of given. You may mention there. That is given. Now what happens then? Therefore these two triangles, triangle AMP, congruent triangle BMP. Congruent triangle BMP means by which test? By triple S test, these two triangles are congruent. Hence then what will you take? Angle AMP congruent angle BMP corresponding angles of congruent triangles. If angles are congruent, therefore measure of angle AMP is equal to measure of angle BMP. Thus now we have to write, but these are angles in linear pair. These are angles in linear pair, and hence we will take that angle AMP plus measure of angle BMP is equal to 180 degree. So what happens? Measure of angle AMP plus measure of angle AMP is equal to 180 degree, and thus twice measure of angle AMP is equal to 180 degree, and therefore then what happens? Measure of angle AMP is equal to 90 degree will come. It will come 90 degree. Measure of angle AMP is equal to 90 degree. Okay. Thus, therefore, AMP, therefore P lies on line L, that is, P lies on perpendicular bisector of seg AB. By this way, we can prove this theorem. You may, by any how way, it is so simple. Here, when AMP is equal to 90 degree will be done, then we should have to write seg PM perpendicular seg AB, and thus then P lies on line L, that is P lies on perpendicular bisector. Is any point which is at equidistant from the end points of the segment, all that points are always at equidistant. Those points are at equidistant, they lies on perpendicular bisector. Now students, there is one more theorem, that is theorem number 4. I am going to explain, and I hope that you will understand it. There is need that you should have to concentrate, and after concentration, after studying it, anyhow you should have to do practice. Okay, now we are going to study about last one theorem, angle bisector theorem. Angle bisector theorem. What is angle bisector theorem? That we will see. Every point on the angle bisector, every point on the bisector of an angle is equidistant from the sides of angle, Then here we should draw one angle. Then I am going to draw here angle ABC. Angle ABC is one angle. Every point on the bisector of an angle. This is BD. You may take BD. BD is angle bisector. So in given we should mention that ray BD is angle bisector of angle ABC. Then what do we want to prove? That you should have to prove how this AD, we should prove how AD is equal to, we should have to prove that here in given there is need that we should have to mention that this construction, it is a part of construction. Draw here DA perpendicular BA and DC perpendicular BC, and you should prove, what will you prove? You should prove how AD, every point on the bisector of an angle is equidistant, means AD is equal to CD. Okay, we want to prove this. So then how will you prove? It means that area we should have to prove triangle ADB and triangle CDB are congruent. So how are triangle ABD and triangle CBD? Any name you may take. that how these two triangles are congruent, that you should have to prove. And then side AD is equal to side BC. That is the answer. So here I am writing here proof. In this proof, first I am going to write that ray BD is angle bisector of angle ABC. What is reason? Given. The reason is given. Now angle ABD congruent angle CBD. Okay, this is number 1. What is the reason? Because of angle bisector. Means these two are congruent. Okay. Now DA here is given. DA perpendicular DA given. Therefore angle A is equal to 90 degree. Similarly DC perpendicular BC at C. Therefore angle C is equal to 90 degree. These are 90 degree. Now we will enter in triangle. How these two triangle ABD? I am taking here in triangle ABD and triangle CBD Okay. What? BD, seg BD congruent seg DB. Okay, common sides. This is common in both triangles. And angle ABD congruent angle CBD from 1. Here it is, we have proved. And angle A congruent angle C, 90 degree angles. Therefore triangle ABD congruent triangle CBD by SAA test, and therefore then side AD and side AD congruent side CD, corresponding sides of congruent triangles. Therefore AD is equal to CD. Hence D lies on angle bisector, or sides are equidistant from the, what we can write, that every point on the bisector of an angle is every point is D lies at equidistant, D lies at D. Here we will erase that and we will mention that D lies, or you may directly write that every point. Hence D lies at equidistant. Similarly, you should mention that. What will you mention? Every point on the bisector of an angle is equidistant from the sides of angle. By this way, this theorem is here completed. Now, similar way, we can write another one theorem, but you can solve theorem from page number 41. What is told that any point equidistant from sides of an angle is on the angle bisector. Any point equidistant from the sides of an angle is the bisector of the angle. That theorem you should try to solve yourself. If not understand, please ask me. Thanks for watching our video.